Welcome back, students. We have a question. Example 9.6. We have to integrate 0 to 1 2x positive 7 divided by 5x squared positive 9 times dx. I can rewrite this as integral 0 to 1 2x divided by 5 times x squared positive 9 times dx, positive integral 0 to 1 7 times dx divided by 5 times x squared positive 9. Now, I would consider this first. Consider integral 0 to 1 2x divided by 5x squared positive 9 times dx. Now, what I'm going to do, I'm going to use substitution method. So, let 5 times x squared positive 9 be equal to, say, t. I differentiate both sides. So when you differentiate both sides, you get 5 times of differential of x squared is going to be 2 times x. Of course, you have the dx there, positive. Differential of 9 is 0. Again, you have the dx there, the differential operator. On the right side, when you differentiate t, you get dt. So this can be rewritten as 10 times x dx is equal to dt. So what happens to this integral? So therefore, integral 0 to 1 2x divided by 5x squared positive 9 times dx can now be rewritten as, I've got 10x dx as dt. So what I'm going to do, I need to have a 10 there, but I don't have a 10. So I would multiply the numerator by 5 and the denominator by 5. So now I would have 10 in the numerator. Of course, the denominator is going to be 5x squared positive 9. Of course, you got a 5 there. So this is rewritten as 1 over 5 integral 2 times 5 gives you 10x dx. So now 10x dx can be replaced with dt. Now 5x squared positive 9 is taken to be as t. Now we have a formula. What is the formula? Integral dx over x is ln x positive constant c. Now, if I were to use this formula, of course, you can use, instead of ln, you can also replace it as log. Since your textbook is using log, I will also use log here. So this is equal to 1 over 5 times log t. But what is t? T is 5x squared positive 9. But this entire thing as a limit is 0 to 1. Now, I have not changed the limits here. I have not changed the limits here at all when I made the substitution. I just kept it as it is because it's a little bit complicated if you want to change the limits for t. So I kept it as it is, and then when I resubstituted for t, now I would substitute the limits. So this is going to be 1 over 5. It's a constant. It's taken out. I substitute the upper limit. So it's going to be log of 5 of 1 squared positive 9 negative log of 5 of 0 squared positive 9. So this is what we would be getting. Now this is equal to 1 over 5 times log 5 times 1 positive 9 would give me 14. Negative log of 9. Now I can rewrite this as 1 over 5 log of 14 over 9. Why? We have a formula. So what is the formula? Log of a negative log of b is equal to log of a over b. This is the formula from logarithms, so we can use that formula. So I have a value for the first part. Now we need to go to the second part. So what I'm now going to do is I'm going to use the word consider. So make sure to use this word consider. Consider integral 7 times dx divided by 5 times x squared positive 9. I'm going to rewrite this as 7 times integral dx divided by, now 5x squared. What I'm going to do, I'm going to take this 5 out. Okay, so if when I take 5 out, I would get x squared positive 9 divided by 5. Now you will know why I'm writing it like this. So this can be rewritten as 7 over 5 integral dx divided by x squared positive 3 divided by root 5 whole squared. So I'm going to be writing it like this. Now, why am I writing like this? Since we know that WKT stands for, we know that integral dx divided by x squared positive a squared is actually tan inverse of x over a, with the 1 over a being in the front as a multiple of constant positive c. So this is the formula we know already. So because I know this formula, I'm going to be changing this to represent this formula which we have already know. So now this can be rewritten as 7 over 5, it's a constant. Now dx divided by x squared positive a squared. So it's going to be 1 over a. In place of a, it's going to be 3 divided by root 5 times tan inverse of x divided by a. X over a is going to be 3 divided by root 5. Of course, the limits are going to be 0 to 1. So I just substitute the limits as 0 to 1. Now I rewrite this as 7 divided by 5. I flip 3 over 5. So it's going to be root 5 divided by 3. In fact, I'm flipping 3 over root 5 times tan inverse of x divided by. Now, when I flip it, it's going to be root of 5 divided by 3. Okay, the limits are 0 to 1. Now, if you substitute the upper limit, you would get, in fact, let me rewrite it as 7 times root 5 divided by 15 tan inverse of, I substitute the upper limit, so it's going to be root of 5 times 1 divided by 3. Negative, I need to substitute the lower limit, so I would be rewriting it here. So this is going to be 7 times root of 5 divided by 15 tan inverse of root of 5 times 0 divided by 3. So let me place it into parenthesis. So this is what I'm getting. So of course the part with the root 5 times 0, this would be off. So giving me 7 times root of 5 divided by 15 tan inverse of root of 5 divided by 3. So this is what I get for the second part. Now what we can do, we can rearrange this part. We can rearrange this part to represent the solution in the textbook. So how do I rearrange this part? Now this is going to be 7 times root of 5 divided by, now 15 is actually 5 times 3, right? So now 5, what I'm going to do is I'm going to rewrite 5 as root 5 times root 5 times 3 times tan inverse of root of 5 divided by 3. So this is what I would be doing with the solution that I have got. So now this can be rewritten as, now root 5 can be cancelled, giving me 7 times over, or I would say 7 divided by 3 times root of 5 times tan inverse of root of 5 divided by 3. So this is what I have got from considering the second part. Now we need to write the final solution, right? So therefore the final solution, see, actually considering the second part, or I would say considering the first part, we add a solution as 1 over 5 times log 14 divided by 9. So you should have this in mind. So this is part 1. This is part 1. And this is part 2. So this is going to be part 2. Okay, so if we are going to add part 1 and part 2, so therefore we add part 1 with part 2. So when you add it, what do you get? So this is going to be equal to, this is 1 over 5 times log 14 over 9 added with 7 divided by 3 times root 5 tan inverse of root of 5 divided by 3. So this is the final answer to the question.